Hello everyone, my name is Abhishek and welcome back to my channel. Do you know 95% of AI agents never reach production? They work absolutely fine on the local machines, but the moment you start putting them in production, they start breaking. So in today's world, building an AI agent is not a big deal. The main challenge is running the agents reliably, making sure you handle retries, making sure you handle timeouts, you can schedule them, and most importantly, you can monitor them so that you can go back and see what exactly went wrong. Now, how do you achieve all of this? This is where a concept called AgentOps is trending. In very, very simple words, AgentOps is treating AI agents like traditional software systems. Just like how you deploy traditional software systems and monitor them, you do the same thing for AI agents. In today's video, let's learn AgentOps practically using Flyte. If you are new to Flyte, Flyte is an open source AI orchestration platform and it is very easy to get started. In fact, in today's video, I'll show you how to spin up a Flyte cluster locally using the new feature called Devbox. So we will create a Kubernetes cluster and we will install the Flyte cluster in it. All of that just using a single command. This is going to be a very interesting lecture. AgentOps is super cool. So just make sure you watch the video till the end. So to understand AgentOps better, let's focus more on the problem statement. I'll show you how easy it is to build an agent. And then I'll also tell you why is this agent not production ready. Let's take example of a weather agent, an agent that can predict weather of a particular region. We can build this agent in 4 simple steps today. Step 1, we will start with defining a tool that can fetch the weather data. This is a code snippet. As you can see, this can fetch the weather data and whenever model requires, it can use the data. Step 2, once we have the tool defined, we will define the model and we will connect model with the tool. So this way, whenever model needs the tool, it can invoke the tool and we can use LangChain here. Step 3, we will use LangGraph to define the flow of the agent. For example, node configuration, router configuration, or graph configuration. We will do all of that using LangGraph. And finally, step 4, we will invoke the agent or we will run the agent. That's all. Using these 4 steps today, you can build any AI agent. Let's see. Let's put these code snippets into a Python file. Then let's create Google Gemini API key and let's try to invoke the agent. Let's see if it works as expected. I'll first head to Google AI Studio where I can create a free API key. In fact, you can use your OpenAI key as well. But for the purpose of the demo, so I'm here, I've created using create API key and this is my API key. It comes with limited runs, but for the demo, it should be good. Now I'll go back, I'll export it using the export command. So just export Google API key followed by the key that you got from Google AI Studio. Then I'll create the weather agent. So this is going to a Python file, weatheragent.py, and the code snippets that we have. Now let's save this file and let's try to run it. Python 3, weatheragent.py, and let's give it with the prompt. Prompt, how is the weather in Hyderabad on 20th of Feb 2020? There you go. So it says the weather in Hyderabad on 20th of September 2020 was 27.3, 28.1, 29.3, 31, and 33.2 degrees. So you got the response from the AI agent. But if you observe carefully, this setup is missing several important capabilities. We haven't taken care of deployment. We might still have to spin up a Kubernetes cluster and deploy the agent onto the Kubernetes cluster, which is a very tedious activity. This is not even taking care of scheduling. This is not taking care of task management. We haven't implemented retries. We haven't implemented timeouts. And most importantly, as I even mentioned before, we haven't implemented observability. Let's say someone wants to understand what actually went wrong in 20th run, or probably what actually went wrong in the agent run that took place 10 days ago. We don't have the observability data, which is a primary drawback if you want to build a production ready agent. This is exactly where Flyte can help. Let's first see how to install Flyte. As I told you, it's super easy to set up a cluster. It just takes a single command. Once you install and configure Flyte, then I'll show you how you can update the existing agent. That's the best part. If you have an agent written in Python, you don't have to rewrite it with Flyte. You can just update your existing workflow with the Flyte configuration. Let me also show you that. But first, let's set up Flyte. Basically, we can install Flyte using Python pip. So it's always a good practice to create a virtual environment first. Let me call this as .flyte. I'll source the virtual environment using the source command .flyte bin activate. Perfect. So now we have the virtual environment activated. We can just run the command pip install Flyte TUI, the terminal user interface. Of course, it's good to put this in a single quote, and we should have Flyte installed. Now, there is only one prerequisite. You should have Python above 3.10. So if your Python version is less than 3.10, just try to upgrade your Python version. Cool. So we have Flyte installed now. We just need to run this command, Flyte start Devbox. Now, what exactly this command does? Within a Docker container, it will spin up K3s cluster, and within the K3s cluster, it will have the Flyte installed for you. So basically, you will have a Flyte cluster ready on your local machine. So for this, you should have Docker running. If you don't have Docker, just install Docker Desktop on your Windows or Mac, and it should absolutely work fine. Even on Linux, you can install Docker because it just needs a Docker container. Now let's see by running Flyte start Devbox. So there you go. It is pulling an image, and within next 30 seconds to 1 minute, we should have the cluster ready. So we have the Flyte UI running on localhost 30,080, and image registry is also configured. We can access the user interface and we can configure Flyte from there. Let me quickly open and show you. So this is the user interface, again running on port 30,080. So from here, you can choose the domain. Let's say you're working on different environments, development, production, staging. You can switch between the domains. In fact, even if you're working on different projects, you can start setting up your project and switch between the projects as well. However, I prefer using CLI for configuring the domain as well as the projects. So I'll go back to the CLI and quickly run this command, Flyte create configuration. So this is going to create config on the endpoint localhost 30,080. I'm creating a project name called Flyte Snacks. It's up to you. You can create any project name. For example, Abhishek. And the domain is development, builder, local, and we are establishing an insecure connection because right now it is running with HTTP. Now, as soon as I do this, you will notice a local configuration file is created. This configuration file is updated with the information. Let me quickly open this for you. So there you go. This is the endpoint, insecure connection, domain name, and project name. And whenever we have the first run, so when I trigger the agent through Flyte, you will also see the information reflected on the UI. So as soon as we have the first agent run, you will notice a project is created, and within the project, you can also see the runs. We are going to do that. But before that, what I want to show you, Flyte is also very secure. So previously, when we were using LangGraph and Google Gemini agent without using Flyte, we were using the Gemini secret, the Google API key through environment variable. In Flyte, because this is a Kubernetes driven setup, you can create a Kubernetes secret and you can store the Gemini API key, or it can be OpenAI AI key, whatever it is. You can store all your sensitive information within the secret. And it's also super easy to create. You just have to run the command Flyte create secret followed by the name of the key, in my case Google Gemini API key, project, and the domain. Now it will ask you to enter the secret value. Just provide the Gemini API key, whatever you get it from the Google AI Studio. Just paste it here and your secret is stored. Now let's verify if the secret is created. You can just run command Flyte get secret. So you don't have to get into the container and interact with the Kubernetes cluster. We can actually do that using the Flyte CLI. So now whenever we need Gemini API key, we can just reference this Flyte secret. Nice. Now that we learned how to install and configure Flyte, let's focus on some core concepts of building blocks of Flyte. In fact, we will use some of these concepts to transform our weather agent. We already learned about projects and domains. Just for quick revision, you can set up a Flyte cluster. You can use it across the organization. You can use domains to switch between dev, staging, production environments. And you can use projects to switch between different projects within your organization. So from administration point of view, projects and domains are very helpful. Then there is an important concept called task environment. Personally, I feel this is the most important concept of Flyte. I'll make it very simple. When you trigger an agent run within Flyte, a container is set up for you, right? So when you use Devbox, a Kubernetes cluster is set up for you. Within the Kubernetes cluster, you have the Flyte. When you use Flyte to trigger an agent run, a container is set up for you, which is running within the Kubernetes cluster. But you have to define the configuration of the container. Do you want an Ubuntu container? Or do you want it with certain packages? Do you want to restrict resources of the container? All of that can be done using the task environment. Then there is something called tasks. Like tasks are the Python functions that execute within the container. So within your agent file, you have different Python functions. The Python functions that execute within the container are called as tasks. And we will decorate those functions using the task environment. Then there is something called runs and actions. This is how Flyte tracks and manages your execution. So obviously you're going to run the agents. So what Flyte does, it uses the runs and actions to manage the executions of these tasks that you're going to execute. Finally, there is something called apps. So apps are basically the long running services for APIs, dashboards, and inference endpoints. So these are the long running services. You can learn more about these core concepts using the Flyte documentation, which I'm obviously going to share within the description. But for the Flyte demonstration that we are going to perform, we will use task environment, tasks, and runs. Obviously, projects and domains, we have already configured that. In fact, let's see that in action. For the purpose of demo, to make our weather agent to production ready agent, I duplicated this file. I named it to weather agent with flyte.py. And trust me, I just had to make two simple changes to the file. One, I had to define the task environment. As I told you, task environment is a crucial component. So I defined the task environment. First, I imported Flyte. Then using Flyte.task environment, I started defining configuration for the container. So I named the agent as LangGraph Gemini agent. Then I'm using the secret Google Gemini API key. If you remember, we created this on the Kubernetes cluster. I'm not providing the value here. I'm just referencing that secret that we created. So it's completely secure. And finally, I'm providing the list of dependencies for the containers. Basically, for this agent to run, we need LangChain, we need LangGraph, we need requests, we need sentence transformers. I'm providing all of that as dependencies so that once the container is started, it has all the dependencies installed. Now, once we define the task environment, of course, we have to use it for any of the tasks. I'm using it for the main task. So main function is responsible for the complete invocation. So what I've done, I've decorated the main function using env.task. So now if I just execute this function, basically what is a task? Any function that executes within a container in Flyte is called as a task. So now this main function will be executed as a task within the Flyte configuration. Let's see that. Now I'll just run this command, Flyte run weather agent with Flyte, and let's provide a simple prompt even in this case. Hyphen prompt. Hi, what is the weather of Hyderabad on 20th of September 2020? Now you will get almost the same response, but what's important here? How Flyte transforms this agent into a production ready agent. If you see, we have a URL here. So I'll just copy the URL. I'll paste it here. You will notice. See, you can start tracking the execution. You can also track the output. Okay, it says, I'm sorry, I cannot fetch the weather forecast. There is some intermittent issue. The good thing is that in Flyte, you have an option to rerun. So you just have to click the rerun. Whenever you are running into intermittent issues or API issues, you don't have to go back to the terminal. You don't have to trigger the run again. You can do it from here. You can also check the logs. End of the day, this is a container that is running within a Kubernetes cluster. So you can check the logs. You can also check the Kubernetes events. If there is some issue, you don't have to go back to the Kubernetes cluster. You can track the events from here and you can see if something actually went wrong. You can also look at the task configuration. So this is the same task configuration, the Flyte internal configuration, the main function that we triggered. Further, you can also head to the task and you can see the complete task configuration. But Abhishek, where do I see the previous runs? So to the left side, you have an option for runs. So these are list of runs. Let's say you want to go back and see the run that was executed 4 days ago. You can go there. You can see the logs. What is the status of the run that was executed 4 days ago? So this is how monitoring also works. So this is a very useful telemetry information. You can also set up triggers to Flyte. So let's say you want to schedule your agent or agent runs. You can do that. Scheduling has become a very important thing with agents these days. With Flyte, just create the configuration same way that we did before in your Python file, that is in your agent file. Once you import Flyte, just add this one line here. Right? Once we define the task environment, immediately you can define flyte.trigger.rly so that you can schedule your agent runs. Cool. So now let's go back to the runs and see what is the status of our rerun. Perfect. Now this time it is successful. So in case of intermittent failures, you can just go back and run the rerun option. And finally, if you want to track the advanced metrics, like let's say the CPU quota or memory quota, this is only part of the enterprise plan. You can easily upgrade to enterprise. Like let's say you start using Flyte and you like the AI orchestration part of it. You can just use this upgrade to enterprise and you can go with one of these options. You can go with the team or the enterprise option. Of course, you can chat with the union team members and see what fits the best for your organization. I'll add more details in the description, like how to get started with Union, how to get started with Flyte. You will find all the useful links in the description. Cool. And I also want to introduce to a very interesting option. So if you head to the Flyte documentation, so there is this option, demo Flyte to in a browser. Like let's say you want to initially experience Flyte even without setting up Devbox or even without setting up anything on your local machine, you can use this Flyte to live demo. So you have different options here. There are some basic agents. There are some advanced AI agents as well. So you can switch between these options and you can experience Flyte from the browser. For example, this is similar LangGraph Gemini agent that we built. You can just run and track your executions from here. Anyways, so to sum it up, AgentOps is something very, very cool. These days, everyone is working on building agents, but end of the day, you have to get these agents to production. And that is exactly where Flyte comes into picture. As you have seen, it hardly takes 2 to 3 configuration changes to bring your existing agent to a production ready agent with Flyte. Just go through the Flyte documentation, after watching this video, and you can learn more about the Flyte core components. Once again, I'll share all the useful links in the description as well as the pinned comment. Please go through it. And I hope you found this video insightful. I hope you learned something about AgentOps and this open source AI orchestration platform, Flyte. If you have any questions, do let me know in the comment section. Thank you so much for watching the video. See you all in the next one.